Hi there, this is Mr. Mizell. This chapter we're looking at water and soil pollution. This first diagram I have up here kind of looks at some different ways that pollutants can enter into an environment. And if you take a look around, what are some ones that you recognize? So water pollution is a global problem. So it's something that multiple countries and multiple people are dealing with across the world, and especially in developing countries, and mainly for access for disease-free water. And because of this concern, there's a huge push for sustainable water use, which really means clean and enough water for everyone. And one of those ways of doing that, or getting that clean water in a sustainable manner, is using wetlands. All right, wetlands can be basically a natural way of cleaning water. So wastewater can come into a wetland, and a wetland can act almost like a wastewater treatment plant, where it has primary, secondary, and tertiary cleaning of water. And primary is really to remove solids. So solids kind of get trapped by this rock bed. And then, as it goes through the secondary, that is where biological processes happen, where you get absorption of pollutants by plants. You also get a lot of bacteria breaking down the nutrients, or taking out the nutrients from the water, and other types of chemicals or pollutants. And then last, you have the tertiary, and that's kind of the only one where humans will intervene in this process, where we collect that water after it's passed through a wetland and treat it with chemicals like chlorine to remove some of those last disease-causing agents or other industrial organic compounds. Now, the types of water pollutants: you have sewage, disease-causing agents; sediment pollution, nutrient pollution; organic, inorganic, radioactive substances; and thermal pollution. So looking at sewage pollution to begin with, because sewage, where does it come from? Yeah, it comes from humans. And problem here is they can contain disease-causing agents, especially if the people that pass them along were sick. It's also a huge source of nitrogen and phosphorus, and by introducing or adding those nitrogen and phosphorus nutrients, you can create enrichment, which I'll talk about here in a second. Soaps and detergents that are used a lot by humans that get into wastewater or get down through wastewater contain a lot of phosphorus. So those as well are nutrients. And then there's this biological oxygen demand, which kind of has to do with enrichment. Biological oxygen demand is really the demand for oxygen for living things in water. And oxygen dissolves in water. And when you enrich water, which means you basically add nitrogen and phosphorus, is basically adding that nutrients, who does really well to begin with? Yeah, plants. Plants do really well with that nutrients. And as those plants spike, they eventually do what? Yeah, they die. And then who does well there? Dead things? Who likes dead things? Yeah, decomposers. I'm going to just write Alright, decomposers do really well. So as the decomposers do really well, what do they use? Yeah, they use dissolved oxygen. So as those plants live and die, decomposers thrive, and then the oxygen goes down. So that dissolved oxygen drops. And who do you think is going to be affected by that? Yeah, any other living thing that uses oxygen. So around this level, when your dissolved oxygen concentration is so low, you get what is known as let's see if I can use my mouse here. Fish. Writing with my tablet now. Fish kill. Write that here. Fish kill. There we go. So a fish kill can happen when you don't have enough oxygen. And that's because of enrichment, adding those nitrogens and phosphorus. So that's sewage pollution. So disease-causing agent pollution. This is really bacteria, viruses, protozoa, which are single-cell plants, and parasitic types of organisms like worm. Some examples: we have cholera, typhoid, and schistosomiasis, which we talked about. You can see, like during a flood, So individuals have to walk through water or move through water. You can have diarrhea increase dramatically because of protozoa. You can have cholera come about if people ingest that water. Typhoid, which is something that I had to take medicine for before going to South Africa. Hepatitis also spreads in it. And if you have more water in an area because of a flooding area, that does carry these diseases in, but also it can promote insect growth, and malaria could increase as well. I see some individuals here in a developing country drinking from just a direct waterway without it being treated that possibly could have disease-causing agents in it. So how would you monitor to make sure or see if there was disease-causing agents within this? Well, one way to use it is called a fecal coliform test. And it looks something like so. It's almost like a petri dish that has a certain agar or chemical in it that allows bacteria to grow. And if you get bacteria of a certain color, that will indicate E. coli. And if there's E. coli, what do you think that indicates? Where's E. coli found? E. coli is found naturally within living things in their intestines, especially mammals. So that would tell you that sewage is present within that waterway if you have an increase of E. coli growth. So there's disease-causing agents. Then we have sediment pollution. What do you think sediment pollution is? Yeah, I've got a great example here of sediment pollution, and you can really see the difference between the clear water and where it's being polluted. And really, that is just solid particles within the water that get into the water because of erosion, logging, degraded stream banks, strip mining, overgrazing, or construction. And you can see down here with this diagram, you've got an area that has sediment pollution occurring. What's it lacking on the sides that it has over here? Is vegetation. What does vegetation do to soil? It holds it in place. So if it doesn't hold it in place, you're going to get more of that solid suspended particles into that water. And if there's more solid suspended particles, what do you think is going to reduce in that water? What's not going to be able to get through down below? Yeah, light. You're not going to get as much light going through. So if you don't have as much light, what are you going to miss out on in the water? It's photosynthesis. So therefore, you're not going to get plant growth. Now, you can have different levels of water and sediment pollution. And how do you think you would measure how much sediment pollution is within the water? Now, if you think of Who's Killing Crystal Creek, the lab that we did earlier, what was one way that you could test to see how much solid particles are in the water? Yeah, you could use a Secchi disc. Kind of here, you got a Secchi disc. As you drop it down, it measures turbidity, which is really the amount of solid suspended particles in water. So there we go, we got sediment pollution here.